Trigonometric functions of all angles. The right-angled triangle definitions of the trig ratios only hold for angles between 0 and 90 degrees. But we would like sine, cosine and tan to be defined for all angles, or at least as many angles as possible. This requires a new definition, but one which is consistent with the definition of the trig ratios for angles between 0 and 90 degrees. A long time ago, the definition was extended so that the likes of cos 147 degrees could have meaning. The trigonometric functions cos of A and sine of A are defined for all angles A using the unit circle. This is a circle with the centre 0, 0 and radius length 1, which is why it's called a unit circle, because it has a radius of 1 unit. Starting from the positive side of the x-axis, anti-clockwise angles are taken as positive and clockwise angles are taken as negative. So here we have the unit circle with a centre 0, 0 and a radius length of 1 unit, and it passes through the points 1, 0, 0, 1, minus 1, 0 and 0, minus 1. Consider the triangle shown opposite and the point xy on the unit circle. So here's the triangle, and this is the point on the unit circle called xy. We have angle A, and I'm going to label the y as opposite because it is opposite the angle, and this side of the triangle, which is opposite the angle, has been labelled as y because this is the point xy, so we can call this length y. The x has been labelled as A, the adjacent, and the 1, because remember it's 1 unit of a radius, has been labelled as the hypotenuse. So consider the triangle shown opposite and the point xy in the unit circle. From the trig ratios, we have cos of A equals x over 1, which is equal to x. So remember, cos of x is equal to A over h, the adjacent over the hypotenuse. The adjacent is going to be x, so we have x as the numerator, and the hypotenuse is 1. So we have 1 as the denominator, and x over 1 is x. So cos of A is equal to x. Sine of A is equal to y over 1, which is equal to y. Remember, sine of x is equal to the opposite over the hypotenuse. The opposite is y, the hypotenuse is 1. So we have sine of A equals y over 1, which is y, so sine of A equals y. Thus, x comma y is equal to cos of A comma sine of A. Because remember, cos of A is equal to x, and sine of A is equal to y. So x comma y is equal to cos A comma sine A. So this point here on the unit circle, this point xy, is actually cos A sine A. It is natural to extend this definition to all angles of A in the elements of the real number set. Thus, in theory, to find cos of 147 degrees, we rotate from the positive side of the x-axis through 147 degrees in an anti-clockwise direction. So this is the positive side of the x-axis. This entire horizontal line is the x-axis, and this particular part here is the positive part of it. So what we do is we rotate anti-clockwise. And we keep going until we get 147 degrees. So this would be 90 degrees. This would be a right angle. If we keep going as far as here, we get to 147 degrees. This point on the unit circle, so this point right here in the unit circle, at the end of the radius has the coordinates cos 140 degrees, comma, sine 147 degrees. So this point here is cos 147 degrees, sine 147 degrees. A calculator gives cos of 147 degrees as being equal to minus 0.8387. And it looks about right. If we think that that's 0 and that's minus 1, then that looks to be about minus 0.83. So it matches up with the unit circle, which looks reasonable from the diagram. Likewise, from a calculator, sine of 147 degrees equals 0.5446. So this point here on our y-axis, so if we think this is 0, this is 1, this is just past the halfway mark, so that's about 0.54, so that looks about right as well. Which again agrees with what we would expect from the diagram. Tan of A is defined in terms of cos A and sin A, just as it was for acute angles, i.e. tan of A is equal to sin of A divided by cos of A. Thus, to estimate tan of 147 degrees from the graph, we could write tan of 147 degrees equals sine of 147 degrees divided by cos of 147 degrees, which equals 0.5446 divided by minus 0.8387, which gives us minus 0.6494. Remember, if you're using your calculator and you're using sine, cos, or tan, it must be in degree mode. Reference angles. The reference angle, or, for any angle A, is the acute angle to the nearest horizontal. Or, which is the reference angle, is calculated differently for A in each of the 4 quadrants. So remember, in the unit circle, this is the first quadrant, this is the second quadrant, this is the third quadrant, this is the fourth quadrant. For example, let's start with quadrant 1. If we're trying to work out the reference angle for an angle inside the first quadrant, so for example 60 degrees is between 0 and 90 degrees, then the reference angle is just equal to that angle itself. So in the first quadrant, the reference angle is equal to the angle itself. So for example, if A is 30 degrees, then OR is 30 degrees. If A is 45 degrees, then OR is 45 degrees. If A is 80 degrees, then OR is 80 degrees. So any angle in the first quadrant, so any angle between 0 and 90 degrees is just equal to itself. The angle A is equal to the reference angle. Now let's have a look at the second quadrant, which goes from 90 degrees to 180 degrees. So for example, if A is 150 degrees, which lies inside the second quadrant, then the reference angle is 180 minus the angle. So 180 minus 150 is 30 degrees. So if we ever want to find the reference angle for an angle that's in the second quadrant, we take 180 and we subtract that angle from it. So 180 minus the angle A will give us the reference angle. Now let's have a look at the third quadrant. The third quadrant lies between 180 degrees and 270 degrees. So let's say, for example, our angle is 225 degrees, which lies in the third quadrant. Then we say the reference angle will be 225 degrees minus 180 degrees, which leaves us with 45 degrees. So if we're looking for an angle, if we're looking for a reference angle of an angle inside the third quadrant, it's the angle take away 180 degrees will give us the reference angle. And lastly, let's look at the fourth quadrant, which lies between 270 degrees and 360 degrees. So let's say, for example, we have angle 300 degrees. What we're going to do to get the reference angle is say 360, take away 300 degrees, leaves us with 60 degrees. So for any angle inside the fourth quadrant, to work out the reference angle, we're going to do 360 degrees, take away that angle. So you need to learn off the rules by heart. So in the first quadrant, the reference angle is equal to the angle. In the second quadrant, the reference angle is going to be 180 degrees minus the angle itself. In the third quadrant, the reference angle is going to be the angle itself minus 180 degrees. And in the fourth quadrant, the reference angle is going to be 360 degrees, take away the angle itself. So we need to learn these off by heart.